In this chapter, we're going to talk about naming different types of compounds. We're going to break it into three different types of compounds. We have ionic compounds, which are charged substances. We have molecular compounds, and then we have acidic compounds. For all three of these videos, you're going to need a notebook, you're going to need a writing implement. You will also need your periodic table and chart of charges. So once you have all of those ready, let's start. Okay, so we'll start off with ionic compounds. These are compounds that are ionically bonded, and they consist of two different ions. A cation, which is a positive charge. Usually your cation is going to be a metal, and an anion, which is a negative charge. Usually that's going to be some type of nonmetal. Now, some ions are going to be monatomic, meaning that there's only one atom involved. Other ions are going to be polyatomic, meaning that there's more than one atom involved. If you turn over to the chart of charges side of the table, you can actually see that up at the top of the left-hand column, the first ion written there is acetate, and it will say C2H3O2 -1. That's an example of a polyatomic ion. Right, so acetate is all of those atoms bonded together in a structure, and that structure has a -1 charge. Now, in order to form the formula of an ionic compound, what we have to keep in mind is that the compound has to be net electrically neutral. What that means is that the amount of positive charge in the compound has to equal the amount of negative charge in the compound. So we want to combine our two ions in such a way that the positive and negative charges all cancel each other out. You can do this using least common multiple, right? So find the least common multiple of your charges and make them both equal that number. On the next slide, I'm actually going to show you a little bit of a shortcut way that we call drop and swap to accomplish the same task. Naming ionic compounds is really easy. All you do is you take the name of the cation, which remember is usually just the name of the metal. That goes first, and then after that you have the name of the anion, which will usually either be the name of the nonmetal ending in IDE, so that would be your chloride, your iodide, your sulfide, or it will be a polyatomic ion, which will end in ate or ite. Right, so let's figure out how to make these formulas using the method called drop and swap. The way you're going to do this is you're going to start off by taking the symbol in charge for each of the different ions. Right, so if I wanted to take sodium, I would write Na and I would write plus. If I wanted to take oxide, I would write O and 2 negative next to it. After we've written the symbol in charge for each ion, we remove the sign. So we get rid of the pluses and the minuses and just leave the numbers behind. And we reduce those numbers to their lowest ratio. Right, so if I had a 4 and a 2, I'd reduce that down to 2 and 1. After that, you take the superscript of one ion, you drop it down to be a subscript and move it over to the other side. Right, so for example, my oxide has a charge of -2. I take away the minus, it becomes 2. I drop it down to be a subscript, and then I move it down to the other ion, and that's where it stays. And if you're working with a polyatomic ion, you have to do something special to that if you're dropping a number next to it. If you're putting a number next to a polyatomic ion, the ion has to go inside of parentheses. Right? Whenever you drop something, let's say, next to sulfate, you're not going to say SO4 3. You're going to say parentheses SO4, close parentheses 3. So let's try a couple of examples. I'll go over a couple first, then I'll have you try one, and then we'll do a couple with polyatomic ions. Right, so we'll start off with magnesium and nitrogen, so Mg and N. First thing we have to do is look up their charges. Magnesium has a charge of +2. I got that from the chart of charges on the back, or I could use the periodic table. Magnesium's in group 2. All elements in group 2 have a +2 charge. Right, so Mg +2. Nitrogen is in group 15. All things in group 15 have a -3 charge. So N 3-. I'm going to take away the plus and the minus. I'm left with Mg with an exponent of 2, N with an exponent of 3. And now what I'm going to do is I'm going to drop and swap them. So I'm going to take the 2 move that down to be the subscript of the nitrogen, take the 3, move that down to be the subscript for the magnesium, and what I wind up with is Mg3N2. That is the formula for the compound formed between magnesium and nitrogen. Right, the charges cancel out, and the name of the compound, well, Mg is magnesium ion, negatively charged nitrogen, negatively charged elements end in ide, so this becomes nitride. So Mg3N2 is magnesium nitride. Now if we try strontium and oxygen, again, strontium is in group 2, its charge is +2, so Sr +2. Oxygen, or oxide in this case because it's going to be negative, has a -2 charge. Take away the plus and minus, so now I have Sr with an exponent of 2, O with an exponent of 2. The 2's can reduce down, right? 2 and 2 can reduce down the ratio. They become 1 and 1. So now I have Sr with a 1 and O with a 1. Drop and swap the 1's. Sr1, O1. We don't write 1's in our final formula, so we just get SrO, which is the formula for the compound strontium oxide. So what I want you to do is I want you to try this one right here. This is the compound that forms between aluminum and sulfur. So take a couple of minutes, pause the video. Once you think you have an answer to it, unpause and we'll go over it. Make sure to use your periodic table and chart of charges to get the charges, though. Okay, so what we have, aluminum has a charge of +3, sulfur has a charge of -2. Get rid of the signs. Drop the 3 down to the sulfur, the 2 down to the aluminum. We have Al2S3, and the compound is called aluminum sulfide. Right, so that's working with a binary compound. Now we'll do a couple of examples of the polyatomic ion. I'll do the one over on the left, and I'm going to have you guys do the one over on the right after we do that. Right, so ammonium oxide. Ammonium's not an element, ammonium's a polyatomic. We have to find it on that chart of charges. Now, because it's written first, that means it's positively charged. So it's going to be in the plus column, the second one. The formula for the ammonium ion is NH4 with a +1 charge. Oxide, just like we had on our previous example, is going to be O with a -2 charge. I take away the plus and the minus, so now I have NH4 with a 1 above it, then I have O with a 2 above that. Drop and swap the 1 and the 2, and now we're going to have NH4, 2, but notice that the NH4 now has to go in parentheses. I'm putting a 2 next to the NH4 group, so it goes in parentheses. Again, the reason why we want to do this, if I don't put in the parentheses, I have NH42, which I don't think is right. I also don't multiply to get NH8. I don't add to get NH6, and I don't distribute to get N2H8. Right, we just say NH4 because that's the structural unit for ammonium, and we have 2 of them, so parentheses 2. And then oxide, we just have O, right? So ammonium oxide, NH4 in parentheses, 2, O. So I want you to try aluminum nitrate. Pick the video back up when you think you have an answer to that. Alright, aluminum nitrate, Al, has a charge of +3. Nitrate is NO3 with a charge of -1. Get rid of the pluses and minuses. Now we have to drop and swap. We're going to drop and swap the 3 from aluminum down to the nitrate. But because we're moving a number next to the nitrate, I'm going to put NO3 in parentheses. Right, so we're going to get NO3 in parentheses with a 3 outside. And then the 1 from the nitrate, it's a 1. I can move it down. I don't have to because we don't write 1's anyway. So aluminum nitrate, Al, parentheses NO3, close parentheses 3. Right, that's naming and writing the formula for most ionic compounds. In the next video, we're going to cover what to do when you have metals like iron and copper, where they can have different charges, so you have to actually determine which one is which.